Hi, it's Mrs. Pope, and today we're going to talk about dividing polynomials. The main method we're going to talk about today is called synthetic division. Goal 1 is to divide polynomials by monomials, which is what you'll see in example 1. And then we're going to get into using synthetic division. It's a new type of shortcut that we're going to use. So first we're going to do the simple ones. If you have to divide a polynomial, it has many terms, this is a trinomial, divided by a monomial, what we need to keep in mind is that it's really just each term divided by the denominator. So 6x to the fourth y cubed over 3xy plus 12x cubed y squared over 3xy minus 18x squared y over 3xy. So I just basically distributed this amongst each of the terms, and then we're just going to simplify them. So there's really not much to it. It's just simplifying, making sure you put each one under there and remembering your rules. So we're simplifying 6 over 3, of course that's just 2. And then x to the fourth up top, x to the 1 down low. That leaves us x cubed if we subtract. And that would leave us with y squared if we subtract. You could have also done where there's more. Plus 12 over 3 is 4. X cubed up top, x down low. So we have x squared up top. Y squared and y means we're just left with y. Minus 6. We have x up top because 2 and 1. And the y's are going to cancel out. So this is what we would be left with. Really, you just put your denominator under each term in the numerator and simplify. Simple as that. Okay. Now let's get into synthetic division. Synthetic division is a shortcut for dividing a polynomial by a binomial. So, example 1, we want to divide with synthetic division. The other type of division is long division. This is called synthetic. So, it's really kind of neat. It's kind of magical. The steps here, first you want to make sure it's in descending order. Make sure the exponents are going down from greatest to least. And make sure they're not missing any. So we have 3, 2, 1, none. We're good on that. Now we want to write out the coefficients. So we're going to write out 2, negative 13, 26, and negative 24. Now, we have this little setup. You're going to have a little box here. And what goes in here is what would make this equal to 0, what you're dividing by. So you have the binomial, and we just have x minus 4. So here, x minus 4 equal to 0, that would be 4. So if I put 4 in here, 4 minus 4 would be 0. That's what I put here. Now we bring down the 2, and we begin. So here's how it works. You just start with the 2. You multiply. You say 4 times 2 is 8. Add them up and bring it down here. So I got the 4 went from there. 4 times 2 was 8. And then I'm going to take negative 13 plus 8. I'll get negative 5. Now, start over again. 4 times negative 5 is negative 20. Add them up. 26 plus or minus 20 plus negative 20 or minus 20 is going to be 6. Multiply again. 6 times 4, 24. Add them up. 0. So we have no remainder here. That's nice. So the way this works, this last number is the remainder. This would be the constant. This would be the x term, and this is going to be the x squared term. So to write your final answer, we have 2x squared minus 5x plus 6 with no remainder. So had you taken this and done long division, you'd have gotten the same answer. Maybe that's something you should try out and make sure that you do. All right, let's look at another example. So we're going to take this polynomial divided by this binomial. So remember, first step, is it in order? 3, 2, 1, none. Yes, that's good. So now I have to write my coefficients. 2, 3, negative 4, and 15. In my little box over here, what would make this parenthesis equal to 0? Negative 3. So we'll bring down our 2 and get started. Negative 3 times 2, negative 6. Add them up, bring it down. Negative 3 times negative 3, 9. Add them up, bring it down. Negative 3 times 5, negative 15. Add them up, 0. Again, we're left with no remainder, which is nice. Doesn't always happen, but it did these last 2 times. So this is our remainder. This is our constant. This is our x. This is our x squared. So our final answer, 2x squared minus 3x plus 5. And if you wanted to check your work, you could take this, multiply it by x plus 3, and I bet you would end up with this. At least I hope you would. That's just one way you could check your work. All right, let's look at another example. Example 4. So we have our polynomial, a minus 2. All right, that's good. Let's check our exponents. 4. Uh-oh, we're missing a cube term. We can't miss any terms in this. We need to have a place value of that. So I'll show you how to fix that. So 4, if we add a 3, 2, 1, none. Okay, the way we're going to take care of that is we're going to take the 4. That's the 4th term, the term with exponent of 4. We're going to put a placeholder here. Make sure we understand we don't see that there. Let's put a placeholder here. That's for the cube term that's missing. It should say 4, 3, 2, 1, none. So this is the 4th power, 3rd power. Then we have the squared, the a term, and the 12. So 4, 0, 2, negative 4, 12. And then of course over here, negative 2. Let's bring down the 4 and get started. So try it out. Negative 2 times 4, negative 8. Add them up. You get negative 8. Negative 2 times negative 8, 16. Add them up. You get 18. We see what's happening? Keep going. See if you can beat me. Where are we? Negative 2 times 18, negative 36. And make sure we're adding here. Look, we have a negative 36 and we have a negative 4. So make sure you get those together with negative 40. Watch your signs. Be very, very careful. Negative 2 times negative 40 will be positive 80. And this time we're left with a remainder. So let me show you what to do with that. We have a remainder, a constant, an x term, x squared, x cubed. So the way we would write it, this doesn't change. Remember, we'll keep this as our remainder. This is our constant. And just write them out. Remainder, constant, x, x squared, x cubed. So the final answer, 4x cubed minus 8x squared plus 18x minus 40. And the way we write our remainder, plus, since it's positive, 92 divided by a plus 2. We always write our remainders this way. You write the remainder over the original divisor. So 92 over a plus 2. There's our final answer. Thanks for watching, and remember you are responsible for your own learning.